Welcome to the Sargassum Champions course. You are currently tuning into one of the videos produced for this course. Funding for the course comes from the Resilience, Sustainable Energy and Marine Biodiversity Program, RESEMBID, financed under the 11th European Development Fund, EDF, Caribbean Overseas Countries and Territories Regional Program. RESEMBID is being implemented by Expertise France, with the primary stakeholders being the 12 Caribbean overseas countries and territories. Let's get ready to learn together.
Welcome, listeners, to a special episode of the Sargassum podcast and one of our courses for the Sargassum Champions course. With me today is Miriam Philippi. She's a postdoc at the Alfred Wegener Institute, and she works on determining what makes sargassum grow as part of the Seas for Society consortium that is part of CDR MARE. The research mission of CDR MARE is to investigate whether and to what extent the ocean can play a significant role in the removal and storage of CO2 from the atmosphere. Welcome, Miriam.
Hello, everyone. Thanks for having me today.
So today's special episode is about carbon dioxide removal. And a lot of experts use CDR for short. So during the episode, you will hear CDR a lot, and that means carbon dioxide removal. We will start the episode a bit different than usual. So we start with a short overview of what carbon dioxide removal is and how sargassum could be used for it. Then we hear from Miriam what people on the streets in Quintana Roo, Mexico, think about CDR, followed by some experts' opinions on the topic. Well, let's get started. Miriam, can you explain how sargassum removes CO2 from the atmosphere?
Yeah. So just like land plants and any other macro or microalgae, sargassum can take up CO2 from its surroundings, so either the atmosphere or the water it lives in, and transform this into biomass. And it uses sunlight as an energy source to do so. And this biological process is known as photosynthesis, and it basically allows sargassum to grow. And during this process, while consuming carbon dioxide, a byproduct is actually oxygen. And our atmosphere, and therewith the air that we breathe all the time, is composed out of around 21% oxygen. And by now we know that at least half of this oxygen in the air that we breathe comes from photosynthetic active organisms living in the ocean, like sargassum. And the carbon that is taken up through this process of photosynthesis is mainly stored in carbohydrates, such as sugar, starch, and cellulose, and that then build the biomass of the organism, and in this case also of sargassum.
So that means in sargassum there's a lot of carbon stored that used to be CO2. But to actually remove the CO2 long-term from the atmosphere, we don't only need the sargassum to take it up. We also have to make sure when the sargassum dies, it isn't released back into the atmosphere, because then the sargassum will just store it very short-term, which is called the short carbon cycle. So for the carbon to go back into the long carbon cycle, where the oil, for example, was laying, we need the sargassum to sink. So sargassum does sink naturally to the deep sea. If it gets old and it loses its aerocysts, so the little bubbles you can see on the sargassum, it will sink. Also, if there's storms that push the sargassum deep enough that makes the bubbles burst from the pressure, it also sinks. So there are natural processes that make the sargassum sink, and deep sea explorations have found a lot of sargassum in the deep sea. Of course, not all the sargassum sinks. So some sargassum actually ends up on our beaches, as you know. And when it rots on the beaches, it releases methane, which means the carbon that is stored in the sargassum is released as an even more potent greenhouse gas. So that means the good work that the sargassum did, capturing that CO2 from the atmosphere, is actually reversed again and even made worse because it's released as methane and not just as CO2. So we really want to make sure the sargassum isn't beaching and is actually sinking, because that actually helps us fight climate change.
Yeah, and so what we want to talk today about is the idea of enhancing this natural process of storing sargassum carbon in the ocean, for example. And there are several different options how this could work. So one of them would be to sink some of the sargassum artificially to the deep ocean and make sure that it stays in place there. And there are two ways how we could do that, either by harvesting the natural sargassum that is now growing, for example, in the Great Atlantic Sargassum Belt, or by artificially growing even more sargassum to enhance this process before sinking it down to the deep sea. And there are a few studies in literature already that show that the sunken sargassum in the deep sea seems to be more or less stable over time. So basically a good storage for this carbon in the deep ocean. However, we still need long-term observations to confirm that this is actually the case. Another option would be to use sargassum as a source for products. So to store the carbon in long-lived products that last longer than 100 years, for example. And some of this could be bioplastics, biochar, or building material. And finally, researchers have found out that the sargassum, while growing, it does not store all its carbon in its particulate biomass, but it also excretes some dissolved organic matter, how we call it. And this organic matter is very rich in carbon. And studies with closely related macroalgae have shown that this dissolved organic matter has the potential to stay in the ocean for long term without being degraded by the light or by microbes. Meaning that this dissolved organic matter that is excreted by the sargassum has the potential to be another major sink of sequestered carbon. And upcoming research in this field will hopefully soon shed some light on the amounts of the carbon that are excreted by the sargassum and how long it stays stable in the water column. And I guess in the end, the idea of enhancing all these processes is to sell carbon credits for the work that you do and for the carbon that you sequester by growing more sargassum or by harvesting the natural sargassum.
Yes, and carbon credits can also be sold for when a fossil fuel product is substituted with a non-fossil fuel product. For example, when biofuels are made out of sargassum. This, however, is not considered CDR or carbon dioxide removal, because the CO2 that has been stored in the sargassum is actually released soon after it has been captured back to the atmosphere when you're burning the biofuel. However, it avoids fossil fuel emissions. So we are able to keep more gas and more coal and more oil in the ground and not burn those. So that's why it really helps us to reduce our current emissions of CO2 and reduce the amount of CO2 that is still being added to the atmosphere every day. So both of these, the CDR and the avoided emissions, are important to investigate. We need both the reduction in emissions and a lot of reduction in emissions. And we also need to take the CO2 that's already in the atmosphere out of it. That's the two things that the IPCC report has been telling us we need to do to stay under 2 degrees Celsius or even stay at 1.5 or below degrees Celsius. Unfortunately, we cannot do just one of the two because the job that we have created for ourselves by waiting too long to address climate change or moving too slowly while doing so made it necessary that we do both things now and do them rather quickly. For today's episode, we are not focusing on making biofuels. There are some of our experts who talk a little bit about this, but we are really just focusing on carbon dioxide removal and not the avoided emissions from the biofuels.
Yeah, so to now sell carbon credits from our carbon dioxide removal approach, one actually has to show and prove that the carbon dioxide from the atmosphere is sequestered. And in order to do so, there's a process in place that we call the monitoring, reporting, and verification, short MRV. At the moment, there is no commonly agreed on MRV strategy for Sargassum CDR yet, but there are certain things that are very likely to be part of the Sargassum CDR MRV strategy. And this includes to measure the amount of the carbon that is present in the Sargassum biomass and the amount of the biomass that we sink to the deep sea, for example. We also need to demonstrate the flow of the carbon dioxide from the atmosphere to the Sargassum biomass, and there was basically proof that there's a reduction in CO2 concentrations in the atmosphere. We also need to follow the fate of the Sargassum carbon, either in the deep sea or in the dissolved organic matter fraction in the water column, or of course in the products that are made out of the biomass. And we have to make sure that the carbon stays in place and is not released back to the atmosphere in the form of CO2 or methane. And finally, we also have to measure all the CO2 emissions that happen during the process of creating this CDR option, to basically account for the emissions that we're producing during the process. And in the end, we also have to monitor all possible side effects that are happening while we apply this method.
Exactly. And carbon credit projects, of course, also have to show that they do not any harm to the environment and the local community. I don't think anybody working on carbon credits wants to solve a problem and create another problem in the meantime. So everybody's trying really hard to find a solution that is not doing any harm and is not creating another big problem. For Sargassum CDR specifically, there needs to be environmental impact assessments of what happens in the deep sea, if there's any negative effects there, and also at the surface where the sargassum is harvested and potentially grown. So we have to look at, is there any bycatch? If it is grown, is there any impact on phytoplankton, on the ocean itself? These assessments can also uncover positive environmental and social side effects. And our experts are going to talk a bit about the positive and the negative ones they expect to see when these assessments are done. And if you have a positive side effect in your carbon dioxide removal project, then you often can ask for a higher price for your carbon credits. So those extra benefits are often paid by a higher price by the people who buy the credits. Let's talk about the opinions of our non-experts from Quintana Roo in Mexico on what they think about sargassum and CDR. The people of Quintana Roo, where I live as well, belong to the most heavily affected by the new sargassum influx in the Great Atlantic Sargassum Belt. So Miriam, what did you find out?
So yeah, in July 2022, we performed a population survey in Quintana Roo using paper questionnaires. So we asked random Mexican people on the beach, in bars, restaurants, and hotels to fill out these questionnaires that we handed out. And yeah, so we started with assessing first their age, their gender, their profession, the time of the residency in this area, and also their educational background. Next, we followed with the section on the coastal environment and the ocean, and the participants' perception and meaning of these terms. So what does the ocean and the coastal environment mean to them? We then followed with a section of questions about climate change in general, and also on Sargassum and the effects these new Sargassum influx events have on them and their society. And finally, we explored their opinions on using Sargassum for business purposes in general, and also, of course, for CDR. In total, 27 people participated, and they were mostly between the age of 20 and 40 years. And the majority of them lived in the area already for longer than 5 years. And only one of them was actually no local resident. We found that tourism was the main income of most of the participants, although they had varying educational backgrounds and trainings. On a general note, the survey was very limited with only 27 participants, which of course does not allow for a decent representation of the local community of Quintana Roo. And also the non-verbal format of the questionnaire made it hard for us in the end to interpret the results, as we don't know in the end how the participants interpreted the questions to begin with. But still, I think this questionnaire study provides a first insights into the opinions of at least some of the resident individuals.
Cool. So that sounds like a lot of work. How did the participants feel in regards to the coastal environment and the ocean?
So for most of the participants, they described the ocean and the coastal environment as a place of peace, health, and relaxation. And they all indicated that they used the ocean and the coast for recreational activities in their free time. But also a lot of the participants indicated that they associate the coast and the ocean also with their place of work and their profession, most likely due to the tourism that they work in. We also found that the participants had mixed opinions about the current state of the coastal environment, but that the majority thinks that the state is not improving in the future, showing that they are rather concerned about the developments in that area.
And what is their understanding of climate change and the support of carbon dioxide removal in general?
So, based on the questionnaires, we found that the participants had a rather good understanding of the term climate change. They mentioned things like the problematic and threatening nature, the changes in temperature, and also the human involvement in climate change. We found that the majority of them was concerned about climate change, and they also almost all agreed that they think that climate change is caused by humans. They all see that climate change will most likely have negative effects on their personal life and also the local and global society they live in. They also indicated that they would support research for enhancing natural processes for carbon dioxide removal and for the development of carbon dioxide removal techniques. Yet it is hard for us to think of what they actually pictured when we asked these questions. And finally, we also found that some of the participants indicated that they don't feel well informed about climate change and the consequences. And I think this is a very valuable information.
Yeah, it is. So there definitely needs to be a lot more information going that way. Of course, when sargassum is used as a viable carbon dioxide removal method, this will create a type of industry, and people are needed to work in the companies who will be selling carbon credits. So likely it will be people local people in those areas where the sargassum is collected that will get jobs in these industries. So did some of the people maybe even really well suited for this, because the area has been working with sargassum for a long time, and there's a lot of people already working in the harvesting part and the management part of sargassum. So how do people in Mexico feel in general about using sargassum for businesses?
Yeah, so first of all, we found that the participants associate only very negative things with sargassum. They mentioned the smell, the pollution of their beaches, and also the negative socioeconomic effects that these influx events have. They also agreed with the statement that these influx events are caused by climate change. And some of them still indicated that they think that there might potentially be economic benefits from the sargassum in the future. So there's at least the hope to turn this negative phenomenon around and do something positive with it. The problem that we saw is that the vast majority of the participants did not know any companies or businesses that involve sargassum yet. But they all indicated that they support the idea of creating companies and businesses that involve sargassum and the usage of the biomass in the future. And finally, they also indicated that they would support the idea of doing research to find out how sargassum could be used to mitigate climate change. We also asked them a few basic questions on sargassum and how it grows. For example, if sargassum can take up CO2 and produce oxygen, which is of course true. And what we found was very surprisingly to us, that a high number of participants actually admitted that they don't know the answer to these questions. And I think, this is very, very striking that they didn't even want to make a guess. They could have just said yes or no, but they admitted that they simply don't know. And taken together, I think that the participants are willing to support the idea of turning the sargassum crisis into an opportunity, and that they're willing to support actions against climate change. The problem that I'm seeing here is, however, that they are not yet capable of bringing these two ideas together, since they're lacking the basic knowledge that connects sargassum to the mitigation of climate change.
Wow. It always strikes me very weird that even though there are so many companies here in Quintana Roo who are working with sargassum, that it's not very much public knowledge. And for example, the person who made a house out of sargassum blocks, he's known around the whole Caribbean, and he's made international news, but a lot of local people don't even know about his project or other projects. So I'm not surprised of what you found, but I'm surprised that it is that way. But I do also find that when I talk to people day to day. And yes, I'm somehow not surprised that people don't really know how algae are photosynthesizing and how they're using the CO2 and the O2. Because at school, in Switzerland and other places as well, it's always talking about land plants and not algae. And maybe that's where we have to start at the schools and teach people about algae. So what do you think is needed to happen in order for the public to accept and support sargassum for carbon dioxide removal? And what do you think are the chances that this could be realized?
So I think the most important issue that we just talked about is to tackle the transfer of knowledge from the scientists and the companies who are already working with sargassum to the public. Some participants indicated that they don't feel well informed on climate change and the consequences. And they also didn't know the answers to these basic questions on sargassum growth that we asked. They also didn't know companies or what can be done with Sargassum already. At the same time, some of them expressed their hope that they could get economic benefits from Sargassum in the future. So I think what is now key is that our scientific knowledge and the knowledge of the products that can already be produced by the companies, that this must be transferred to the public more often, better understandable, and on channels that are actually used by the public. And this will then hopefully help them to make informed decision on what companies, institutions, and even carbon dioxide removal approaches to support in the future. We also asked them in the questionnaire who they think is most likely to solve these issues, so the Sargassum crisis and turning this problem into an opportunity. And they indicated that they would trust most scientists and NGOs to find solutions for this problem. And we also found that they apparently use social media, followed by friends and family, as their most common source of news. So maybe that would be something to start with. And I think if we do that, if we get the public informed on the basics and what can already be done, I think that there might be a good chance to get their support for Sargassum-based carbon dioxide removal and also for the production of products from Sargassum biomass.
Yeah, I think so as well. And just when I'm in the collectivos, I see everybody on their phone watching reels and watching TikTok. So yes, a lot of people do get their info from social media today. And maybe we have to get good at making these really short videos that people consume for hours and hours every day and make them popular.
Yeah, and make science fun.
Exactly. So as I think it was really interesting to hear what the public of Quintana Roo was thinking. And next we will pivot over to our experts, and we gave them a few questions, which I will read one after one. And after each questions, we have the expert answers given. So all the experts are going to introduce themselves, and then afterwards you hear their answers to the questions I'm posing. So they weren't all in the same room at the same time, but I hope you enjoy their answers and their insights as well. So we sent emails to a lot of different experts, both who are working on carbon dioxide removal, who are critical of it, who are sargassum experts, algae experts, carbon dioxide removal specialists, but not specifically on algae. And we got a few people who replied to us that they would like to answer our questions. So first of all, thank you to all of them. And here I'll let them introduce themselves to you.
My name is Neelakantan. I'm a senior program officer at Ocean Visions, which is a nonprofit organization based in the United States that catalyzes innovation at the intersection of the ocean and climate crises. I manage a program called Launchpad, where we connect companies working on ocean-based carbon dioxide removal with technical advisors in our network of scientific and academic institutions.
I am Dr. Duncan Smallman. I am one of the founders and scientific founder of Seaweed Generation. My background is in marine biology. I live on the west coast of Scotland, and I've spent the last 10 years working within the kind of the seaweed industry. Before Seaweed Generation, I've also done work on the impacts of certain types of seaweed cultivation on biodiversity. So I'm starting to go down that route. And in Scotland, I've worked with West Coast island communities on using their kind of local seaweed resources. And with Seaweed Generation, we're taking that kind of to islands around the world.
I'm Alison Myers. I'm the president of Fearless Fund, which is at fearlessfund.org. And we're a nonprofit and really a research organization that looks at how do we increase ocean productivity? So how do we grow things in the ocean but also at the same time protect the ocean and make the ocean a better place for us having been there.
So my name is Eelco Leemans, and I'm from the Netherlands. I work with Climate Cleanup. That's a small foundation in the Netherlands. And my expertise is, it's difficult to say because I'm working on healthy oceans in many different ways. And my first training was as a master mariner. So I worked on ships as a professional sailor, mostly on sailing vessels. And one of the ships I worked on was the Rainbow Warrior. So that triggered me to start working on healthy oceans. And later I went back to school, studied environmental science. So I'm combining my knowledge, my practical knowledge about the sea, about the oceans, with my knowledge about theoretical knowledge about environmental issues.
Hi, I am Fernández Méndez, and I'm a marine biogeochemist and an algae ecologist by training. I work as a research scientist leading my own group at the Alfred Wegener Institute, and also since recently I am also the CEO of Macrocarbon. I work on sargassum for carbon dioxide removal in the ocean, but also for products, and I'm excited to be here.
Wow, what a great bunch. This is going to be really interesting. So the first question we asked them was, what is your opinion on CDR approaches in general and on nature-based solutions in particular? All right, let's see what they answered to us.
We need CDR. The IPCC makes it really clear we need CDR. So, I mean, this is my view. I'm always happy to share this. I haven't put it up on Twitter yet, but I'm in what we call the or die trying. I'm sometimes a bit gloomy on things. There was a computer game from the 90s called ODT, and it was just like the or die trying stage where we need to give anything and everything a try. So I kind of think it's worth just giving any CDR technique a go. It's going to take a big joint effort. There's never going to be, as humans, we are so fixated on trying to find a single solution for something, and it's never going to be a single solution. It's going to be a big joint effort. So stuff like I appreciate that, like direct air capture, something like that, is very nicely measurable, as is I suppose the production of biochar. There are the MRV, the monitoring, reporting, recording, and verification. Is probably easier for DAC and also biochar, but we always need to consider that the energy input into what the CDR is to achieve that CDR, and especially the carbon input, because it's usually intrinsically linked to the carbon input, which is intrinsically linked to the energy input. So we've got to think of that in CDR. I think nature-based solutions are probably the most low carbon inputs, and I'm really pleased that we are moving away from planting trees. I think like the protection of forests is great, just generally it's important, but trees do, and it depends on the species obviously, but they do take time to properly get going with the sequestration, and I think that we're kind of a bit tight on that time. So for me, ocean CDR definitely is the place to go. It's where the expansion is, and mainly because our planet is 70% covered by oceans. So on that front, I think the nature-based solutions within the marine environment it holds probably our best hope, but because it needs to be measured, I think that is where we're I know what this is probably going to be a question later on, but that's possibly where we're stuck. So I'm very bullish on our CDR approaches. I am trying to be open about all of them, and I think we need all of them.
CDR approaches are needed, and it's not just my opinion. The IPCC report has shown that in order to mitigate the worst impacts of climate change, we not only have to reduce emissions massively, but also we have to develop approaches to remove carbon dioxide from the atmosphere in the order of magnitude of 10 gigatons of CO2 per year. So we need to do the research, and there is no way around it, and the earlier we start, the better. In terms of nature-based solutions, I think they're the best approach to CDR because it basically relies on what nature has already invented. And nature is often the most efficient way to sequester carbon. So, for example, plants and algae have been evolving for years and years to develop the technology in their biomass to sequester CO2. So I think it's a very good approach to mimic that and enhance the natural processes to sequester even more carbon dioxide removal.
So this is a tremendously exciting opportunity for those who like to solve problems. And nature is really our best asset. So nature already does things at large scale. So if we want to remove CO2, which is desperately needed, I think that we should look to nature as our ally. That said, human emissions through fossil fuel use and various activities are having repercussions. It's time to clean up our house. That said, we need to be careful what we do because we are looking at scaling new processes and new biomass production and harvest processes. So we need to follow the precautionary principle. It's a principle of the ocean scientific and political communities. I think it's very, very important, and I think it speaks to CDR and our desperate need to remove and put carbon elsewhere, take it out of the atmosphere. So we have a lot of CO2 to remove and to stabilize our planet.
On CDR in general, I think with the current climate crisis, we cannot do with just, switching over to clean energy because that will not be enough. There's just so many things we really have to do to overcome the climate crisis. So yes, using less energy, switching to cleaner energy, etc. But there's just simply too much CO2 in the atmosphere and in the marine environment. So we have to get part of that out. And I believe that nature-based solutions are by far the best because they have a big advantage in that they can also serve to regenerate ecosystems and biodiversity. And that is something that the technical CDR options do not offer. So I think, and then, sometimes I hear people saying, yeah, we have to use nature to capture CO2. And I'd like to see it in a different way. I don't think we should use nature, but we have to cooperate with nature and work together in drawing down CO2 from the atmosphere and from the oceans. And what is a better way than just to do that with natural ecosystems, like mangrove forests, like seagrass regeneration, like seaweed farming, and also looking into sargassum.
When considering carbon dioxide removal or CDR, it's essential to emphasize that it is not in any way an alternative to reducing emissions. We must reduce global emissions and decarbonize our economy as quickly as possible. That said, there's clear scientific consensus, including in the recent IPCC AR6 Working Group 3 report, that CDR will be required at gigaton scale by mid-century to counteract those emissions that are difficult to abate. This is a huge undertaking, and so we really need to get started right now. It's worth stressing that CDR has to have certain characteristics for it to meet these goals. It has to be captured or drawn out from the atmosphere and stored safely and for a long period of time in geological, terrestrial, or ocean reservoirs, or in long-lived products. The fact that it has to be stored for this lengthy period of time is because any anthropogenic CO2 emitted into the atmosphere stays there for hundreds, if not thousands of years. Storage of carbon dioxide removed from the atmosphere should match that duration. With that context, I feel that classifying carbon removal as nature-based or engineered is a false dichotomy. What is more important is that the removal and the storage is safe, durable, and additional.
Wow, I love the urgency that everybody is putting on solving the climate crisis and the clarity that we do need CDR, but of course also reduction. So next we asked our experts if they think that CDR with sargassum is feasible and scalable. And here's what they answered to us.
Well, yes. The short answer is yes. Seaweed generation, we wouldn't be doing what we're doing if we didn't think it was feasible and scalable. So yes, I do. I mean, seaweed generation are using, the future for dealing with seaweed biomass was kind of viewed as robots, essentially. Like, we know that we need greater mechanization. And that's why we ended up with sargassum, because it was a problem where we could really get the mechanization going, and it doesn't seem to be a problem, and it is a problem. Like, the Great Sargassum Belt is an issue, and it's not going to go away anytime soon. So yeah, in short, yeah, CDR using sargassum, feasible, scalable. There's 20 million tons or so it's got to be scalable.
I think we still do not have a definitive answer to this question. Beyond a small number of modeling studies and studies of natural systems that exhibit similar behavior, there is a lack of information necessary to make well-informed decisions about the effectiveness and environmental impacts, both beneficial and detrimental, of sinking seaweed or sargassum in this case into the deep ocean as a CDR strategy. That's why Ocean Visions, along with Monterey Bay Aquarium Research Institute, published the Sinking Seaweed Framework, which outlines a research agenda that is designed to generate actionable information on cultivating and sinking seaweed at scales that can measurably affect global carbon emissions and the warming associated with it.
Really, we have to use every tool available. We are in an emergency. We work on sargassum, but that said, we are agnostic. If somebody comes up with a better way to remove carbon dioxide, I'm happy to either look at that and work on that with people, or have different systems work together, different processes. I think it's important for us to look at that. The U.S. Department of Energy asked a few years ago if the scientific and aquaculture community could grow macroalgae or seaweed at energy scale for biofuels. And it was such a great question. And it was very interesting going through this process, talking with scientists. But we thought sargassum was the natural species to work with because it floats on winds and currents. It doesn't need expensive or risky farm equipment. It doesn't need a lab or hatchery. So already you've eliminated 2 of the 4 cost drivers for macroalgae production. Sargassum is, as we know, has a new production system in the Sargassum Belt. in the tropical Atlantic between West Africa and the Caribbean and elsewhere. So in some respects, I feel like Sargassum is knocking on our door and saying, use us. We are bioaccumulating the CO2. And now we shouldn't have to figure out everything. Come to the table, meet us at your coast or wherever you can to economically work on this. And now it's up to us and human ingenuity and science and engineering. And I think it's a great tool to use. It's not the only one. I think we have to really look at whatever tools and ideas are out there.
The sargassum that is washing up in the Caribbean and Mexico could be used because it's biomass and there's carbon in it. So it could be used to store carbon. And additionally, if we can find a proper way to make sure that it doesn't wash up on the coastline, then it can also help save, for instance, seagrass fields and mangrove forests, etc. Because if they suffer, if mangrove forests suffer, then and die, they will also release a lot of carbon. So by taking sargassum from the shore, and in itself, you already do good work in avoiding carbon release. Now, then, if you take it away from the shore, then there's a lot of different things you can do with it. And some of those things could also be used to capture carbon, or to avoid carbon being released.
My research shows that carbon dioxide removal using sargassum is feasible and scalable. However, it needs to be done in a certain way. So not every way of doing it will be good enough. And so that's why we need to study exactly where to do it, how to do it, where are the nutrients going to come from, etc.
So sinking of biomass to the deep sea is on the table. We have done that 3 times to 4,000 and 5,000 meters in very small amounts. We deployed sargassum to these depths, and then we retrieved it about a year later and analyzed the biomass. We thought this was important because the scientific community was saying, this looks like a good idea, but no one really had data, especially for the deep sea. It was all coastal, and unless there are projects that I don't know about. But in any event, we did this each year, and then would retrieve the biomass after a year and redeploy in an attempt to gather data. What we did not have in doing this was a budget. And if you do not have a budget, you can't really measure the impacts to the biota and the chemistry. So this is what's needed. We believe that this is going to take a certain amount of time, and there's going to be contention in the scientific community. So while we think it's very important to start this work, it is not ready for prime time, and it is certainly not ready for scale. So this is just, one opinion, recognizing the severity of the state of the planet. So it's tempting, but we don't know about impacts, and we also lose valuable compounds when we send the whole biomass to the deep sea. So there's more than just carbon in sargassum. And when thinking about transforming our economy for new ways of doing things, we shouldn't waste. That's one of the core principles. So while it's tempting, we're not big advocates of this at the moment. I'm open to persuasion, but I don't think we're there right now. And in the meantime, we have a biomass that needs management because it's currently coming on the coast and being collected by bulldozers and heavy equipment that is eroding our beaches. So I think that we need an interim strategy of converting the biomass to products. Long-term storage and products, I would say, should be our focus. And our team of marine engineers, chemists, remote sensing experts, we're working on this.
Sinking is another thing that we have been thinking about, but I think it's complicated, and one of the complications is that you have to get a permit from the London Convention to sink it, and so it could be done as a sort of a test case, but then you really need to monitor it very well. You need to have a proper protocols, etc. So that means that then you also need to find out what it would do once it's on the bottom of the ocean. So you can imagine that if you would collect, let's say, I don't know, 10 tons of CO2 of sargassum, bring it to a deep place, sink it there in a controlled way, and then monitor what is happening there. That is really, really, really complicated and very costly as well. So I think from a practical point of view, that's a bridge too far. And it's strange because in the Sargasso Sea, it sinks by itself. So I've been thinking about it, and I was wondering, because in the old days, seaweed has also been used as a construction material, like for instance for roofs, etc. So I was wondering if that could be a possibility, to just let it dry and then turn it into panels or so, or something that you can use for construction material. We collected sargassum in 2020 on the island of Sint Maarten, Dutch part of Sint Maarten, and shipped it to Holland. And part of that sargassum is now, there's another organization doing tests with it. One of the tests is to see if they can turn it into biochar.
People do use sargassum for other things. Our co-founder, Professor Mike Allen, he spent almost a decade working on finding other uses for sargassum, and he just said the best use for all of it is probably sinking. So when people find other uses, that means that they can use some of it. Great, we can help harvest it and give nice fresh sargassum.
Wow, that's even more interesting. Very much a bit of a disagreement on how to do it best, but all of them have really cool ideas of how to use sargassum for CDR. So let's talk about a bit of what are the hurdles that we are still facing to make this happen, to implement sargassum-based CDR. Are there any things that still need to be researched or still need to get in place for us to actually do this?
I think like a lot of the ocean-based ocean CDR, it's the MRV. It's really proving that it works because sargassum-based CDR is sinking sargassum. So, I mean, there's the technological hurdles of collecting it and then getting it to sink and then making sure it's sunk. But in the grand scheme, that is kind of a relatively small hurdle. We can harvest it, we can collect it when it's probably still pretty fresh, we know we can sink it. We can sink it without bailing it as well, and it's just convincing people that is the CDR, that the surface ocean water, the air exchange means that by it growing and you're removing it, and then the remaining bits still grow and take up more carbon dioxide, that drawing in of that CO2 on the surface water is the same as basically taking it from the air, because the exchange is so rapid generally that you're taking it in, and by the time the surface has taken, I'm explaining this so poorly, but yeah, it's essentially, it's just convincing and being able to prove that it does work, and then it's also proving that it's not going to, or finding the evidence that it's not going to have a negative effect on the deep ocean ecosystems, because the other challenge is it's going to be working at sea. To be honest, like, one of the other hurdles is practically working in the highly exposed oceanic environments, especially for sinking it in deep water below like 2,000 meters. When you're getting to 4,000 meters deep, you're quite a way out, and so those are often quite kind of difficult waters to work in. So yeah, there are some practical hurdles. I think the main one is getting that verification side, and then there's going to be aspects of convincing the kind of the slightly skeptic scientific community, or people who seem to be against sinking seaweed, that actually this is kind of like a right option.
We have the tools. It's a matter of integrating them for a new process while prioritizing benefits to the oceans. So, working in the ocean, as you know, is a matter of resources, logistics, safety. It's many aspects, and each of these areas must be refined to work together, because without all of them, we're not going to succeed. So we need to embed them at the very beginning of the work and make sure all of them are taken care of.
There's a couple of hurdles. One is that it's a seasonal thing. So and the other one is that it happens a lot on small islands where they don't have infrastructure or equipment to deal with it. And that is also tied together. So if you want to have proper equipment, like for instance a boat, a type of boat, you need a big boat with equipment, etc., to take it from the sea. But the rest of the year, that boat wouldn't do anything. It would be idle in the period that there's no sargassum washing up. So that's the thing. It's a capital investment, and the use of such equipment is an issue, which is, especially for small islands, is a big problem. Can be a big problem. Now, for instance, in Mexico, it can be different, because Mexico is a big country, and maybe you can use those vessels for other types of work. And then there's another problem, is that, or a challenge, is that taking sargassum away from the shore when it's on the beach will mean that the sargassum will be mixed with all kinds of substances like sand, or trash, or bird feathers, or shells, etc. So it is a sort of a mixed substance that is difficult to use. Then you might have to clean it again, for instance. So that is an issue. So I believe the best way to do it is to pick it up just before it washes up on shore. Then you only have sargassum, but you also have to be aware of life forms in the sargassum, because it's in itself, floating sargassum is a sort of a micro ecosystem with all kinds of fish and etc. in it. And you don't want to kill those. don't want to distress them. So that's another thing. And then lastly is that the substance of the sargassum, the plants, usually has raised levels of arsenic that make it difficult to use it, for instance, for fertilizer or animal feed, etc.
There are several things that we need to solve before we can implement sargassum for carbon dioxide removal at scale. One of them is figuring out how to keep sargassum in paddocks or aqua farms and make it grow happily, because you need to grow more sargassum in order to make additional carbon dioxide removal. And then the next step is to understand how to process the sargassum and sink it, meaning enhancing the natural process of sargassum sinking, to sequester the carbon for long term in the deep sea. And for that, trials need to be done, where you study not only how the carbon remineralizes or not in the deep sea, but also what's the impact on the benthic ecosystem. And actually the expectations are rather that it will degrade very, very slowly, if at all, and that benthic organisms actually don't really like to eat the sargassum. That's what we observe at the bottom of the Sargasso Sea at the moment.
Also really interesting. So let's talk about co-benefits now. What do our experts think will be side benefits from doing sargassum CDR?
For example, Quintana Roo has had some big landings and some of the top research on the impacts of like marine death. A lot of the environmental impact stuff I've done has been on looking at when a sargassum bloom just comes in and it just kills, and it kills everything. And so, people are worried about, potential negative impacts on the deep ocean. Well, frankly, we've got a lot of sargassum. It washes in, it kills a lot of stuff. It washes back out. It's then going to sink anyway, but then it's having killed a load of seagrass. It's impacting on coral reefs. And so, what it seems is the death, the marine creatures it captures aren't necessarily the oceanic creatures. It's all the coral reef creatures. It's the sea animals in the seagrass habitats, and then it impacts seagrass. So, we've got these two other really important habitats. Like seagrass is known to be such an important carbon sink. It's potentially, enhancing seagrass beds is a major thing in the UK at the moment, because the view is we enhance seagrass, we are enhancing our blue carbon stores, and that because of the way it builds it into the sediments. So one of the key saving graces will be, well, we're protecting the seagrass, we're protecting corals, which, they get called coral reefs. As I know, they get called also algal reefs, because fundamentally the building blocks of a coral reef is those calcium carbonate red seaweeds. So, if you're protecting those, you're protecting two really important habitats that are, whether the coral reefs are necessarily a carbon sink or they might be carbon neutral, who knows, but that is still an essential habitat. It protects, that protects these islands. So that's a key co-benefit. The other is the impact the sargassum is having on people. So the other co-benefit is if you're preventing the sargassum from hitting these coasts, you're preventing, so we could talk about turtles, the impact it has on some turtle species, but we're protecting these people because of the health benefits. It just makes people miserable. We're working in Antigua, and the stories were just horrendous. The impact it's had on local fishermen, the fact it's had health impacts on people, it's had impacts on the tourism. That is such important. Alleviating that, and what I call the human ecology of the coastal environment, I think is a huge co-benefit that a lot of people elsewhere that aren't dealing with it kind of miss?
I think a co-benefit could be that saving coastal ecosystems like mangrove, seagrass, coral reefs, etc. That's a co-benefit. Another co-benefit could maybe be for tourism, because in some places, there's big bundles of mats of sargassum washing up on the beaches, and that's not nice for the tourists. And maybe another co-benefit could be a local small scale, setting up a local small scale industry. So it could be useful for a local economy.
So currently, as we all know, sargassum floats on currents and winds and arrives at the shores of Caribbean and other coasts. And it's causing economic and environmental harm. So, as I said, sargassum is just coming to our shores saying, we're here, good to work with it. But currently, we're not really managing this new system as it arrives on the coast. And it's causing harm to carbon sinks of mangroves and seagrasses and corals. It's depleting oxygen, and management would be a way of stopping the harm that is going on now to coastal economies and ecosystems. And we can also work with sargassum as a biomass for the economy. So it's an opportunity that engages both stopping harm and also producing new, products in new ways. And we desperately need this for a new kind of economy.
There are several co-benefits that can come with growing sargassum in aqua farms and using it for carbon dioxide removal. One is that the aqua farms, if established in areas of the ocean where previously there was not that much life, like the subtropical gyres, they can create oases in the middle of the desert and actually attract biodiversity. So sargassum is a great habitat for crabs, for shrimps, for fish, for turtles, and also for dolphin and other bigger mammals. Another potential co-benefit that still needs to be demonstrated is that as you bring organic matter to the deep sea, you might enhance productivity there as well, but also you might create artificial reefs where more life can grow, in the same way as when a boat sinks, it basically, after a few years, it's full of life growing on it. So the bales of compressed sargassum can act as a reef as well in the deep sea.
I love their commitment to helping the Caribbean region and Africa with the sargassum problem. I think we all are happy to find solutions for that, and that sargassum CDR could be one of them. But we also have to be wary, because there could be negative effects, and we don't want to create a problem by trying to solve another one. So we also asked our experts what kind of negative effects would likely occur.
I would say with the deep sea, we don't really know, because all models on decomposition are generally within shallow waters. And when you get sent a model about sewage or like how stuff has decomposed, it's always in coastal waters. So though you do get these low oxygen pockets also you get the data from fish farms where it settles, and you do get these kind of decreases in biodiversity. You get these pockets of deoxygenated water. When you're getting to 4 kilometers below the surface, I think a recent paper said that the microbial rate is 30% that of the surface. That means breakdown rate, we know, is a lot slower. The famous Alvin ROV, the sub that sunk, they picked it up again. There was a sandwich in it, and the sandwich was apparently still edible. And that was after 9 months. and it was soggy, but someone still ate it and they didn't get food poisoning. So figured that actually the microbial process is a lot slower. So it's what happens to that sargassum. The sargassum is only going to be a problem if it breaks down. If it doesn't break down, and so it doesn't change any of the kind of physical parameters, it might smother some things, but we don't know. So we do need to monitor that. The other negative impact could be on any surface creatures living in, you're going to probably capture some animals. So it's the degree of how many maybe of those important endemic species in sargassum mats that you're sinking. And the key obviously is avoiding turtles. Let's not take the turtles. So it's making sure that the potential negative impacts are nowhere near, don't outweigh what the potential positive impacts are. And that is all the positive impacts, not just the carbon dioxide removal, but the other bit of it. So there might be negative because you are adding quite a large amount of biomass, but sargassum is already found in the deep sea. There is already a lot of sargassum being washed down into the deep sea, and if you're sinking fresh stuff, then it might actually not have as much of an impact as if you're sending down already rotting stuff. So it just needs monitoring. And I think at the scale that we're going to be doing it and the area we're covering, it's not going to be ever high, dense kind of patches of sargassum. So that's why the monitoring is so important. As soon as you see something fluctuate, change, and look like it's having a negative impact, you just stop, and therefore it gives everything time to recover. I mean, the other one is that there is some talk of how it might affect the phytoplankton. And I know some folk, there's a guy who's been going across doing some phytoplankton monitoring, and he said that what he noticed in the sargassum was that or maybe just plankton, that actually there was very little plankton when you associate with sargassum. So maybe by removing it, we'll get the phytoplankton going again. I don't know. I mean, I suppose another negative is you might be taking quite a large amount of plastic. So we have to figure out actually how much plastic is also being dumped in sent down to the depths. But
possibly a negative effect would be if the sargassum would be harvested too far offshore, that it will kill the let's say animal life that's in the sargassum mats. Yeah.
The negative impacts are, of course, associated to not being able to control the aquafarms and basically the sargassum escaping from the aquafarms. So that might be a problem, but it can be solved. Another potential negative impact in the deep sea is that if the bales get remineralized quickly, then a lot of oxygen will be consumed and you would create anoxic areas in the deep sea. But as I said, that's not what we expect since sargassum biomass is very recalcitrant.
Wow, so there is some potential negative effects, so we have to be careful. And I think the next thing I really want to know from our expert is, given how little we know and that there could be potential negative effects, who should make decisions on whether or not something like sargassum is used for CDR and implemented?
Since I've said that it should be done, the collecting sargassum should be done near shore. That is always within the territorial seas. So that means that the local coastal state, the island state or a coastal state, should have should be responsible for this. But it would be good to also do it in a coordinated way and have an international body to overlook the operations. It would also be good to involve, science research, etc., but then preferably local researchers, local universities.
If we're talking about deep sea sinking, we need to have the ocean bodies weighing in, and we need the scientific community to gain consensus. And the only way that's going to happen is through data, which is going to take some time to collect and analyze. But there needs to be consensus about deep sea sinking. For biomass use for the economy, it seems like that is in some ways a no-brainer. For those teams that can come up with good strategies, it's great. But in the end, we need long-term carbon storage, not just products, if you really want to go for what we need. So I think it represents a near-term opportunity, whether we're harvesting biomass about to beach or we're farming it. Either way, it represents an opportunity, and we should use it, because in the end, only scale matters.
The implementation of any CDR measure needs to be decided at an international level. I think for the research part, so when we start doing the pilots, then the scientific community should lead that and assess the companies, how to do it, how not to do it, assess and in an independent way what are the potential negative impacts, and also document the benefits. And once the approach itself has gone through a process of where we know how to monitor it, how to report, how to verify it, how to actually know how much carbon is sequestered through that approach, then it will basically go through a standard process to verify the carbon credits, and then that project will be given the go to start.
Very interesting thoughts, and I do like that locals are often seen as the people who should be involved, as well as experts in the field, to get to a decision together. I think one of the most interesting things we asked our experts was actually to share any additional thoughts at the end. And what came out there was just amazing. So I'll let you enjoy that. And after those thoughts, me and Miriam are coming back with our debrief.
Ideally, what we would want is not to have to sink Sargassum. But the Great Sargassum Belt is obviously caused by us, by humans. It is a symptom of climate change as much as it is a symptom of, I don't want to say poor agricultural, but maybe it is a symptom of the agricultural practices that are happening in the largest river basins of the Amazon, the Orinoco, and the Congo. And maybe if we could change what's happening there, that would help in terms of generally combating climate change, because let's face it, that's what Sargassum CDR is to help combat climate change. So ideally, it would be nice not having to do this. And I think we've got to be realistic that we've got to. This is a new habitat. It's a habitat that is as man-made as any structure that we put in the water, because it's caused by that runoff, and it's caused by a fluctuation that was to do with probably the North Atlantic oscillation. I think that gets forgotten as well. That it is definite. It's only occurred in the last 11 years, so it's definitely something caused by us, and it's probably one of the biggest symptoms of climate change, as well, the changing climate, as well as changing farming practices. So we just need to accept that, I think, and I don't think that is currently as accepted.
Capital is critical. Working across boundaries, across expertise is critical. You can even extend this to the teams that are out there working, and they may have different goals. Ours is for the planet and to be profitable, because in the end, investors are going to want a return on their investment. So, there's a part of me that wants to put competition and profit aside and to work on the task at hand, which is CDR, whether it's into long-term storage and products, which I happen to like, or, I'm happy to hear ideas from people and help these and help put together teams to work on this. It's that important.
Well, there's an interesting thing I wanted to tell about sargassum, because normally sargassum grows in the Sargasso Sea and a bit on the outskirts. But recently, the past years, there's a lot of influx from sargassum into the Caribbean, and that may well be caused by circumstances in the ocean. And one of the things could be ocean warming of the ocean water. The other one could also be increased input of nutrients into the ocean. So actually, the best thing to do is to solve the washing up of sargassum is to look at the root of this that causes. So if we can, in some way, find a solution for the growing number of sargassum, then the whole problem of sargassum washing up on the Caribbean and Mexico could be mitigated or maybe even solved.
One of the main societal issues of using sargassum for CDR is that it's difficult for people to make the link, because sargassum right now is a nuisance. It's causing lots of trouble in the Caribbean, in West Africa, etc. So I think the key part is to explain the communities why actually preventing that sargassum from reaching the beach and sinking it can lead to avoided emissions, but also how growing more sargassum and sinking it can be beneficial as well, because it's removing extra CO2 from the atmosphere. As well, aquafarming sargassum can contribute to creating a more stable supply chain for sargassum. And so if there are more companies that want to use sargassum for their products, then they know they'd have a stable supply of this feedstock, and then they can upscale. And that's also important for the sargassum economy, growing in countries like Mexico, like St. Vincent, Martinique, Guadeloupe, etc. So they need to have also stable supply of this algae to be able to upscale their processes. I think the most important thing is that we need to try these approaches. We need to investigate them. We need to see how to make them viable. And we need to do that as soon as possible, because we need methods that can be scaled up, and sargassum can grow in many, many places in the ocean without any extra addition of nutrients. And if you add extra nutrients through artificial upwelling, for example, it can grow in huge areas of the ocean. So it's one of the few methods that can really be scaled up in the ocean to reach the gigaton scale. And even then, you don't need a huge area to reach that scale. So it's a very efficient method in itself. So I think we just need to get started to reach speed and scale as soon as possible.
Wow, so we just heard from our experts so much knowledge and insights, and on some topics they all agree, which is great, and then on some of them they very much disagree, which just shows that there's still a lot to do and a lot to research, I guess. Miriam, what did you think?
Yes, so like the local residents from Quintana Roo that we interviewed in our questionnaires, our experts all want to do something about climate change, and they all bring on a sense of urgency and clearly state that carbon dioxide removal is necessary. They also agree that a lot of research is still needed, and despite the urgency, that research needs to be done properly. So we cannot just skip steps on the way. And especially using Sargassum will likely have a positive effect, according to our experts, as it can help to reduce the problems in the Caribbean and West Africa.
Yes, and we definitely all want to reduce those problems. The experts we interviewed, but also had some disagreement, and that mostly was on the best way to do the CDR. So, what to do with the sargassum to capture the carbon dioxide. Some were saying that sinking is the way to go, while others see the path more in making long-lasting products or even use sargassum for products to avoid emissions rather than for carbon dioxide removal. And this is really striking because all of them have spent a lot of time researching the sinking as well as products and make up their mind which of the two is better. And they're on opposite sides in some cases. A strong advantage of sinking is definitely that the CO2 is locked away for a very long time. But however, as Alison pointed out, you also potentially sink other valuable components with the sargassum if you don't take them out before. Products made of sargassum may give you more revenue if you can make more money than with just the carbon credits, and lead to other positive effects like people having those products. But not many products will last for 100 years, so that makes it really difficult to make a carbon sequestration product that actually it is sequestering carbon for 100 years, which is the minimum you need. Maybe our listeners now feel like we gave them more questions than answers. I don't know.
Yes, for sure. But that's also why this is such an interesting topic to do research on. Sargassum definitely has the potential to play a major role in carbon dioxide removal and in the fight against climate change, as one can see from the many people and companies that already work in this field. But there's still a lot of things to be done, especially on the impacts of artificial sinking and how this affects the deep sea and how to measure and report the CO2 that is removed. And I think despite not having all the answers, I'm happy we were able to do this episode together. I think the survey that we did with the local people really showed that carbon dioxide removal has to be discussed in public way more often. And that even at this early stage that we're on, that it is still necessary to do this, even if we don't yet have all the answers.
Yes, I agree. And I'm super happy that you had the time to join me on this journey. We definitely spent a lot of time making this episode together. And that so many of the experts and local also took the time to answer our questions, because without them, this episode would be very short and not very thoughtful, or not have as much information and knowledge in it. And I hope that our listeners enjoyed this different format of the podcast for once. I know it's a bit long, but that they also learned something about carbon dioxide removal that will help them form their own opinion on how they stand on it and how they stand on using sargassum for it. So thank you so much, Miriam. And I also want to thank all the people who helped make this episode. And to our listeners, I hope we have you soon again listening to the podcast for one of our regular episodes.
Yes, also thank you all from my side.
Thank you for tuning in today and learning with us from experts in the sargassum field. This course is made possible through funding by the Resilience, Sustainable Energy and Marine Biodiversity Program, RESEMBID, financed under the 11th European Development Fund, EDF, Caribbean Overseas Countries and Territories Regional Program. RESEMBID is being implemented by Expertise France, with the primary stakeholders being the 12 Caribbean Overseas Countries and Territories. The course was designed by Franziska Elmer and Evelyn Salas, and the videos were produced by Marcel van der Kamp.